All right, number 60 says it's a singular replacement. Now, singular replacement means one element getting together with a compound, and it's going to replace. To figure out if it's going to happen, we first need to look at the activity series of metals. This is in section 11.2. For an activity series of metals, the top one, lithium, will replace anyone below it. Potassium will replace anyone below that. Silver, on the bottom, won't replace anything. So our first step is to look at which one is by itself. If lithium is by itself, anyone else in a compound will be replaced by lithium. It's the most attractive. So number 60 tells us that we have some iron. And it's placed in sulfuric acid. The acids I will tell you, I will give you the formula, you don't have to know those. There's sulfuric acid. So we have a metal, iron, and we have to figure out if it's going to replace hydrogen. So we go to that activity series of metals. Iron is above hydrogen, so it will replace. So hydrogen gets kicked out. And sulfate gets together with iron. The hydrogen gets released. Hydrogen is always diatomic. It always pairs up, so there's two of them. And there's our single replacement reaction. It's already balanced, so you don't have to do anything. For 60B, it says we have mercury going into zinc nitrate. Well, we see mercury is almost at the bottom. So when zinc is already with the nitrate, mercury is less reactive. So mercury won't do anything. So if you mix those two things together, you will have no reaction. And that's what you should put for your answer, no reaction. And then 60C, the halogens are just like the activity series of metals. Okay, group 7, the halogens, just like the activity series of metals. So when we look at these guys, we have to ask ourselves, which one? This one is the most reactive. This will replace anyone below him. Okay, iodine is the least reactive. So that will not replace anything. So in number 60, says I have some bromine. Bromine is diatomic. We have that memorized. It's going to react with barium iodide. Okay, to figure out the right ratio that barium and iodine combine in, we're going to have to crisscross the charges. Barium is group 2. Iodine is group 7. If I'm in group 7, I'm going to gain 1 electron. Crisscross the charges, so my 2 goes down here, my 1 goes down there. So I go back to my halogens. Okay, here's bromine, and here's iodine. Now this guy is above, so he's going to replace anyone below. So this reaction does happen. My group 7 will replace my other group 7. So I'm going to get barium, iodine gets kicked out, bromine moves in. So there's bromine. Again, I have to figure out the right charges, the right ratios. Barium's group 2, bromine's group 7, so again he's going to gain 1. So this 2 goes down here. And then my iodine gets kicked out. And again, he's always diatomic, he's always paired up. Now that I have the right formula, I need to balance it. Alright, so you see, oh, wait a minute. It's already balanced. We're all done. All right, 62. 62 says we have a combustion reaction. Now, with the combustion reaction, they're going to give us the fuel. Now you have to memorize the rest. You have to memorize that it combines with oxygen, O2. You have to memorize it makes carbon dioxide, CO2, and H2O. So those black ones you have to memorize. Now from there, we're going to balance it. These balancing are probably the most challenging of the ones we'll balance. It's a little bit of trial and error. So I'm going to take what I have. I have 8 carbons. I have 18 hydrogens. And I have 2 oxygens. Okay, on the right side, I'm going to list them out in the same order. I have 1 carbon. I have 2 hydrogens. And I have 2 plus 1. I have 3 oxygens. All right, usually a good place to start is with the carbon. So I have 8 on the left. That means I need 8 on the right. So 8 in front of there. Now I have 8 carbons. And I have 16 oxygens. Now I can look to my hydrogens. I have 18 on the left, so I need 18 on the right. So I'll put a 9 in front of there. Now I have 9 times 2, 18 hydrogens. And for oxygen, I have 9 here, plus my original 16, gives me 25. Now, since I have 25 oxygens on the right and only 2 on the left, that's a little bit problematic because I have an odd number here and an even number there. There's no way I can turn an odd number into an even number. Okay, so I need to change my oxygens. So one way you can do it is just take the number given and double it. Let's see what happens. Now I have 36 hydrogens. 18 times 2. My oxygens, I have 18 plus my 16. That's 34. Now I got to fix my hydrogens on the left. Okay, I have 18 on the left, but I have 36 over here. So I'm going to double that whole thing. But now I have 2 times 8, 16 carbons. And I have 2 times 18, 36 hydrogens. Well, now my carbons over here are messed up. I have 8. I need 16. So I'm going to get rid of this and go 16. Now I have 16 carbons. My oxygens, I have 16 times 2, that's 32, plus 18 times 1, 18. So now I have 50 oxygens. Okay, my carbons are balanced. My hydrogens are balanced rather. Now I just need my oxygens. I have 50 over here. I need 50 over here. And that's balanced. All right, letter B you'll see is not as complicated. The process is the same. They give us a fuel, and if they give us a fuel and tell us it's combustion, we need to have memorized that it combines with oxygen, and it always makes carbon dioxide, just like we breathe out, and water, just like we breathe out. Go ahead and bracket those. Just to emphasize, we cannot change the subscripts. We can only change the coefficient, the numbers in front. And I'm going to summarize what I have. I have 6 carbons, I have 12 hydrogens, and I have 6 plus 2, 8 oxygens. Over here, I'll do the same thing. I have 1 carbon, 2 hydrogens, and 3 oxygens. 2 there, 1 there. I'm going to start with my carbons. I like to start with carbons. Who doesn't? All right, so I have 6 on the left. I need 6 on the right. Now I have 6 carbons. That's good. I have 6 times 2, 12 oxygens, plus 1. I have 13 oxygens. My hydrogen, I still have 2. Well, I have 12 hydrogens over here, so I need 12 over here. So I need to take my hydrogens, multiply it by 6. 6 times 2, now I have 12 oxygens. When I change I have 12 hydrogens. I've changed my oxygens. Now I have 6 times 1, 6 over here, and 12 over here. So now I have 18 oxygens. Okay, well I don't want to change this big thing here, so I'm going to change this. I need 18. I already have 6 there, so I need 12 more. 6 times 2 gives me my 12. Whoops. 6 times 2 is 12, plus my original 6. Now I have 18, and now my equation is balanced.